kind of observe this page, and when it goes online, then we're online. Hello and welcome back for one last time. Final exam review. Your questions are welcome for most part. We are going to talk about finding roots or zeros, and I'm inclined to take a look at the one that was on the exam because I don't have any other, unless you have on that review packet. If you have one, do you have one on the review packet? Oh, great. That's all I know. Actually, no, wait, I can actually find it right here. Hold on, give me an hour. There we go. Number 9, you said. Oh, this is the one where you're given roots, and you're supposed to find the polynomial that fits that. So let's do the first one, 3, 4, 3i. So find polynomial. With roots 3, 4, 3i. All right. So it must be, the final answer must be x to the 4th, because we have 4 roots. They gave you 3, but you immediately need to know the 4th, right? What's the 4th root that you need to be able to fill in on your own? Negative 3i. Because you have the complex root, complex roots always travel in pairs as complex conjugates. Since you have 3i, list also must contain negative 3i. Now that is the knowledge that you must have. So now we will write exactly what Jalen said: x minus 3, x minus 4, x minus 3i, and then also x plus 3i. We are going to FOIL first 2, FOIL second 2, then FOIL all together. When we FOIL first 2, we get x squared minus 7x plus 12. And then when we FOIL the second 2, we will get what? Well, let's do this one slowly, because you might be a little bit rusty with these i's. Don't forget that I squared is negative 1. So we have x squared plus 3ix minus 3ix, they all cancel. And then you have minus 9i squared. So that's x squared minus 7x plus 12 times x squared plus 9. And then we FOIL this further. X to the 4th plus 9x squared minus 7x cubed minus 63 x, and then plus 12 x squared, and then plus 108. Combine like terms, x to the 4th, then we have minus 7x cubed, 9 and 12 is plus 21 x squared minus 63x plus 108. And that would be the answer from the for 9a on your review packet. So you have the roots, you create factors, and then you multiply them out. If you have that additional point, then you will multiply this whole polynomial by a, plug in x value, you have the y, and you will calculate a. Yep. Finding zeros, one from exam 3. Exam 3, problem number 7, said f of x is equal to x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12. Guys, the way I create these problems is exactly the way of the previous problem. I say I want roots to be 1, 2, 5, and 9, and I just create factors and multiply them, and I give you the polynomial. Then you have to break it apart. So we start first with the list of rational zeros. It's 12 divided by 1, so technically it's just so possible rational zeros, prs, is going to be all numbers that divide 12, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. So that's 12 numbers. And now you can start checking all of these numbers one by one. The fastest way to check is to use the remainder theorem, and then when you find the root, you immediately divide by you immediately do division of polynomials. So let's check 1. So how much is f of 1? It will be 1 plus 2 minus 7 minus 8 plus 12. That's 0. Got it on the first shot. So 1 needs to divide 1, 2, negative 7, negative 8, and 12. So we have 1. 1 times 1 is 1, and when you add it's 3. 3 is negative 4. Negative 4 is negative 12. Negative 12 gives you that 0. So we already have that x equals 1 is one of the roots. Now we have the next polynomial. You immediately, so the next polynomial that we are considering here is x cubed plus 3x squared minus 4x minus 12. So that's the next step. So we try 1 again. So how much is f of 1? 1 plus 3 minus 4 minus 12. That's not going to be 0, so we have to throw that one away. Let's try negative 1. That's negative 1 plus 3 plus 4 minus 12. Again, different 0. That's bad. Let's try 2. 2. We get 8 plus 12 minus 8 minus 12. Nice. So we immediately do, so definitely x equals 2 is another root. And we do the synthetic division. 1, 3, negative 4, negative 12. 1 times 2 is 2, gives me 5. Multiply, get 10. Get 6, get 12, get that 0. So now we have polynomial x squared plus 5x plus 6 equal to 0, which factors into x plus 2, x plus 3. And we get our 2 remaining roots. And that's it. So now, the most important part is to finish the problem. And that would be to write this polynomial in factored form. Some of you are still confused with it after 2 months of practice. The original polynomial, x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12 has x minus 1, x minus 2, x plus 2, and x plus 3 as factors. This is your answer, right here. If something needs to be presented in factored form, you better present factors for it. There they are. Yes? Descartes' rule of signs is a rule that can help you determine the number of either positive roots or negative roots. And it's useful in a situation when you have very few sign changes. In our problem, we had only 2 sign changes. The sign, as you can see, it started with a positive, and then another positive, and then a negative, so that's 1 sign change, and then a negative again, and then another change right there. So this particular problem had 2 sign changes, which means that at most two roots will be positive numbers. So how does that help? Well, at most 2 roots are positive. That means that you can have no positive roots, positive number like 1 and 3 and 1/2. So you can either have no positive roots, 1 positive root, or 2 positive roots. That's it. Now, we already found x is 1 and x is 2. And that's actually 2 positive roots. So this one, because of the Descartes' rule of signs, couldn't possibly have more positive roots. So that means that just, down the line, you will not be checking positive numbers anymore because you already exhausted the maximum possible amount. It's a theorem that speeds up the process, but generally if you found the 2 roots already, you're already down on a quadratic. You can hit it with a quadratic equation if you want and get the answer. Anything else? Yes.
Can you go over J on the first problem, which is to find the average rate of change from x?
Okay. So the next problem is, what's the number on it?
1j.
Next problem is 1j, average rate of change. What happened? 1j. I got nothing planned. Problem 1. So looking at the picture, I will try to graph this. I mean, I think I can write on this one as well. If I click somewhere over here. Yeah. Well, that's fine. I'll draw the same one so you have it in one document. -2, +2, and 4. Okay, I have this as our graph. First question, part A, is the domain. What's domain? -∞ to +∞, because they both go to the left and to the right forever. Also, you can write double bar R. How about the range? Same thing, good, because they go up or down, so you can use either or notations. What was the question C? X-intercepts. So what do we have? So we have -2, 0. Why -1?
On the graph.
Oh, the -1 on a graph. Okay. Oops. So -1, 0, multiplicity 1, and 2, 0, multiplicity 2. How about the y-intercept? 0, 4. Very good. What else? Okay, so we have part E, increase and then decrease. So E and then F. So increase. So what is the interval for the increasing? Negative infinity to 0. Very good. Union 2 to infinity. Very good. Decreasing has to be the complement, which means 0 to 2. Nice. What else do we have? G, min, max. So G and H. These are all relative. So what is the minimum? 2, 0. How about the max? 0, 4. Very good. And then what else we have? Is f of 200 positive or negative? Answer is positive. Very good. And finally, they're asking us to find what? Find the average rate of change from -1 to 0. So what do we have? The formula for average rate of change is what? Rise over run, the slope formula. Very good. So we have that the f of -1 is 0. It's the intercept. And f of 0 is 4. So we just say it's 4 minus 0 divided by 0 minus -1, and the whole thing is 4. The change is 4. You just read the y values from the graph. If the function is given, you compute those values. If the graph is given, you just read them off the graph. They're always x comma y points. And you just plug in the formula and compute. Yes? Okay. Any other questions regarding number 1 before I close the book on that? (6b). What are we supposed to do? Find the inverse and then graph. So function is a cube root, so we write it as y equals cube root of x minus 1. Then we swap x with y. That's the part to find the inverse. X is equal to cube root of y minus 1. So cube root of y is equal to x plus 1. And then you cube both sides. And you get y is equal to x plus 1 everything cubed. Do not expand this because you can graph it in this form. So the graph This cube function is just moved 1 unit to the left. So it goes to this point. That's how it looks like. So inverse is x plus 1 cubed. That's the inverse. Now cube root of x minus 1, it's right here. And it looks like this. How do we prove that something is an inverse? How do we prove that two functions are inverses of each other? Oh, sorry? They reflect along the 45-degree line. That's one of the ways. Anything else? Yes, plug one into another. Do function composition. If we get x, it's good. If we don't get x. Anything else? Yes. What is the review packet problem for? All the way at the end, I guess? Number 21. No, that's not partial fraction decomposition. That's two. There are nothing on it? Meh. Don't worry about it. Yeah, I can. I'm sorry? 3e. Oh, the problem 3e. I was like 3 times e. That's just a p. It's just a line. Look at the p. But then. Question 3e. We are supposed to graph, I believe, 1/2 something squared. Negative 1/2. Plus 1. All right. How many transformations do I have here? The answer is a lot. We have negative, which is a reflection. We have 1/2, which is a shrink. We have -2, and we have +1. Plus the parenting function, 5 boxes. Now, some of you did not pay attention on the graph on the text on the test. You are supposed to reflect first and then start moving it around for that log question, the second one. So always reflect first, then do the rest. So what do I have? I have a parenting function x cubed, which looks like this. That's all it is. So this is just y equal x cubed, and we walk away. The next one is the reflection. And it needs to reflect on, but look at its odd function. Whether you reflect it on x or y, it's going to look like the same. Sorry, it's going to, both reflections end up being the same thing. So this would be your negative x cubed. Then we are moving to the next. This 1/2 is going to make it shorter. So, I don't know, just make it a little bit fatter, I guess. You can't. Unless you compute points and then dot, then it's just annoying. Move everything to the right, 2 units. Going to 2. Squish. Vertically. And the last one is to move up 1. Now you have points for labeling, so hopefully you will label this to 1. It's only if you're interested in full credit. Otherwise, don't worry about it.
So where does it says to labeling intercept stage, or do you guys figure out if
You can. There they are. Because all you need to do is to plug in zeros, right? Yes.
where are we going to be able to see your grade?
On the line, not for the final, for the whole course. Letter grade will be online.
Do you know by when?
Monday, noon.
So it's either Christmas is a happy day or it's sad day. Because that'll determine my week.
I have no emotion toward it.
That's fine as well.
What happened?
I was fine on Monday. Gonna cry. Yeah.
Any other questions, or we're done?
Oh, yeah, 21.
21?
Yeah,
You should. Otherwise, you're not going to be happy. Which one on 21?
Oh, 21. Second.
Which one?
Can we do 2 of them?
I can do all 3 of them like this.
Let's do it like that. Whoa.
Yes. Yeah. Please. All right, so log 2 of 5 plus log 2 of x plus 1. What do I do, guys?
Well, you're going to take the log out first.
What do we do?
There's only 5 logs.
Yep, single log. 2 of 5 x plus 1. That's it, done. You don't have to multiply it. One half log 2x minus 1 minus 2 log x plus 1. So we first tuck in the exponents. Well, that will be a square root. And that's a square. And then the subtraction goes into Division of arguments, good. Done. See? There's nothing else you can do. There's no need to expand. 4 minus x squared minus ln x. Now what? Cube root, very good. So we have ln of what? Over x, good. So those should be gift questions. Anything else? For 4. Well, you look at the function. Domain is anything that doesn't make denominator 0, so on. But you have 4 different functions. It's polynomial, so all real numbers by the theorem, by default. For all of these, f plus g and f minus g would be all real numbers, and multiplication as well.
The only one that would like be different
Would be division, because you can have 0 in denominator. That's the only one that is bad.
and then whatever. So and if it was not the denominator of x plus 1, you would write that as x in the denominator can't equal 1.
Yes. You set whatever you get, the AB part, you set that equal to numerator, and then you compare the coefficients. No. You would have the whole expression when you add the two fractions together. You'll have the whole expression like ax plus 2bx plus 3b minus 4a, whatever it is. And then you say that equal to 5x minus 5. Can't be that one. You are confusing something there, big time. When you add fractions, you are going to have an expression that has capital A's, capital B's, and X's and numbers. And you set that equal to whatever the numerator was in the original problem. And then you compare coefficients.
For f, if you're doing f of g, you put f, the x, into g, or all the way around?
Which one?
5a.
5a.
F of g.
Whatever is the first is the main one, and you always plug in the second into first. So when you're doing function composition, you always plug in second function into the first function.
And then for the domain of that, it's going to be like all real numbers too.
No, whatever you get there. What are we dealing with? Part A, or polynomials? Yeah. Or if you have square root, can't have negative numbers on the square root, right? Or ln, can't have 0 or negative for ln. Or for tangent theta at every pi over 2, even though it's Precalc1, but there will be other functions.
Almost. I haven't done the first few. But I have everything in the last 2 months, everything is done. Or more than 2. 2.5. That's not on the sheet. Yeah. It's not on a review packet. We can name and class credits we didn't do. I got 20 credits to do. 2 days to enjoy that. I got a lot. What happened? Oh, no. That's a fun question. Cultural. Think about it, write it down. They give you 3 points. Plug them in, and you will get this.
I never did number 7, so.
Yes. It's a total, my total. Well, last week. Hey, Is my too much air to the I just had a 25 on count. It'll get 35 right outside. Somewhere over here. There you go. Yes. So now, when you change that 8 into 4, the whole process repeats again and you get a different function. So technically you are redoing this over and over and the whole thing gets done again. For each one of these values you get to, you did 8, 4, 12, and 16 will change these numbers. Propagate through all of these and change all the numbers.
But I didn't, this, what I did is not, it was not involved in my work, it's the two. Because if I don't have to do this, I'm done. One other thing I have to ask you on behalf of the father. And Melba had the last two, so she did not work out last time, but the problem is. Oh, if you think about it, remember the 21 and one of the questions is 28. So
Every last.
all right, I'll have Melba ask you about it. She did it on, we're gonna get things on it, but she can look for it.
Anything else? 13. I hope I can. 13. Let's see. 13. Da, 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 da. What is 13? 13 is, oh, all possible zeros. Okay, so this is easier version of what we had on the test. Yeah, well, it was on both tests. Finding zeros. So x cubed minus 3x squared plus 4. We will plug in plus 0x as a placeholder. We use the possible rational zeros plus minus 1, plus minus 2, plus minus 4, because that's all of the numbers that we get. And then we start checking. Plug in 1. So f of 1 is going to be 1 minus 3 plus 4, which is not 0. Try negative 1. We get negative 1 minus 3 plus 4. There it is. So we have our division immediately. Negative 1 is going to be 1, negative 3, 0, and 4. Drop down 1. It's negative 1, it's negative 4. It's a positive 4, adds to a 4. And then it's a negative 4 gives a 0. So we know that x equals negative 1 is a root. So now we have x squared minus 4x plus 4. And then this one we can just hit quadratic on it. So it's 16 minus 4, which is again 4 times 4, which is 16, divided by 2. So we get 16 minus 16 is 0. So we just have 4 divided by 2, which is 2. And multiplicity 2, because you have to have 2 roots. So what are the roots? Exactly. But because that piece drops with 0, right? That piece drops with 0. You're losing that plus minus that creates 2 solutions, which means it's multiplicity 2. It's quadratic, squared. You must have 2 solutions.
And then when graphing this, you just plot.
To graph this one, well, this is actually the question probably from before. The same graph. Negative 1 and then multiplicity 2 roots at 2. This is probably the graph that we did earlier.
Oh, yeah.
The negative 1 and then 2 that went something like this. Now whether it goes through 4, I'm not sure, but it looks the same.
And since you're sketching it, you don't need to find the line intercept.
But you could. Oh, actually, wait. It is 4. This is the graph from before. Because y-intercept is when x is equal to 0. That kills x cubed and x squared. Right? So it is a 4 there. Anything else?
For the horizontal axis, can you go over like the 3 rows?
Yes. So for horizontal asymptote, we are memorizing. So this was in 2.6. We are going to have function to be given as a x to the p plus stuff, and then b x to the q plus whatever after. These are the largest exponents. So pq largest exponents. So have a good trip.
Thank you.
So now when you have this, the rules are if p is bigger than q, let's go with smaller first. If p is smaller than q, horizontal asymptote is at y equals to 0. No questions asked. That's the first one. The second one is when p is equal to q, horizontal asymptote is at y equal a divided by b. And the third case is when p is bigger than q, there is no horizontal asymptote, but we have to be careful when p is exactly q plus 1, we have slant.
Only if it's just plus one.
Because slant asymptote is y equal mx plus b. When you do the division of polynomials, they have to be by 1. They have to be off by 1. Otherwise, when you divide, you will get x squared, x cubed, and those are not straight lines.
And then you do the long division.
You do the long division, yes. So if you think about it, so that's that piece. Now, if you have an example, x to the 5th power plus 1 divided by x cubed minus 3x plus 7, these are off by 2, no ha, no sa. Because if you are to divide,
All the exponents, they can only be off by one.
they must be. Not, you know, when you say they can only be, kind of sounds weak. They must be off by 1. Because look, when you divide x to the 5 by x cubed, what do you get? X squared. Which asymptote looks like x squared? None of them, right? So slant asymptote is y equal mx plus b, and that's mx, the first power. So they have to be off by 1. It's a rule. They have to be off by 1. So if it's more than 1, if it's off by more than 1, then it's not. It's no for both.
Wait, I have a question. If I didn't, if I had like exercise that carried over, does that go to the one? Because class assignments are really good. The last version has updates.
I'm posting this.
Are you perfect?
Post it on YouTube.
Huh?
Post it on YouTube. You can do it. If you listen to it, you will hear all the jokes that I made in the day.
Yeah. I do listen.
On your account.
We definitely, yeah, I know. We can hear like our voices and like from the first
You definitely can hear
episode,
it.
let's say. Well, that was the void of me listening to the joke.
No, but they will also. I'll give you some rules.
Are we supposed to have a graphing calculator for Karma?
What happened?
Are we supposed to have a graphing calculator for the Karma?
There will be 2 parts here, I think.
But we should bring a graphing calculator instead of
Yeah.
like. Okay. So I can use him. Keep it out.
On the
Because you're gonna have
calculator
to
part.
graph it? Yes, but I'm keep it out and then calculate.
Yes, on the calculator.
I really like it.
Anything else?
Is it right the time that we're taking it now?
No.
We're taking
It's December
Yeah.
something. You gotta look up online. I think it's 12:30 or something like that.
I think, I don't know.
I think it's 12:30 to 2:30.
12:30.
Yeah.
person works, do we have to put their names on here? Will we credit for having only 2 people? That's so cool. I've also worked with Sun Security. Full section. You get lost. Because like when you do the team the base year, like I really like this. So yeah. So this whole thing is equal to -4, which makes it less negative. So then we're going to sunlight. So drag this equals 5.1 equals I, and then we do the 5.1 equals negative 20. You got it to do it. Now it's gonna be stuck on this script for the next 4 years. Yeah, you delete it.
Anything else?
Oh my god, I feel old. Yeah, you just turned. Wow. Whoa, what? Yeah, whatever. Oh, what? Yeah. Oh,
Anything else? Not, I'm gonna go eat.
Can you stick around 1 second?
All right, let's end the stream, and I will see you all in 2 days.